All right, guys, welcome back to day two of graphs representing change over time. So let's just go ahead and review some of the terms that we talked about. We talked about x-axis, which is the horizontal line. We talked about y-axis, which is the vertical line. We talked about representing data in a scale, which means making sure that our numbers on our side are numbers that they represent the data with um, for example, numbers like if you're going to do them by twos and go 2, 4, 6, 8, and making sure that the data is in like 20, 40, 50, right? If you're not, if your data is like big, then you got to make sure that you're doing a bigger scale. So instead of doing twos, you would do tens, or maybe you can go by 20s. So let's go ahead and just start day two. Today's going to be a little bit quicker. The first thing that I want you guys to do as a class and with your teachers is I want you to go into this data. And your teachers can do this thing called polling. And when you're doing that, poll your students and ask them what is happening over time to the level of the water in the reservoir. You don't have to use polling, but it would be a good tool to start using that technology. Go ahead and discuss this, and I will give you guys about 3 minutes. So you can pause the video now. So as a class, you probably discussed a lot of the stuff that is happening here. You look at this chart that they posted on the left-hand side of the screen, and you can see that it has 30 days, and then it has the water level by feet. So the question that was asked was, what is happening over time to the level of the water in the reservoir? Well, if I look at my numbers over here, I can look that the number on day 0 is 18. The number on day 1 is 17. On day 2, it goes back to 18. And then on day 3, it goes to 17. Then on day 4, it goes to 17 and a half. Day 5 goes to 17. Day 6 goes to 16 and a half. Then 7 goes to 16, 15. So as you're looking at this data, you should be noticing that the number starts at 18, goes down, then comes back up, and goes back down, then goes up a little bit, and then goes back down. But we're not looking at just the 4 days. We're looking at the entire time. So over time, the data that we have collected is saying that the water level is decreasing. And when I say decreasing, that means going down, okay? So it started at 18 and it ended up at 0. So over time, that water level went down, right? It kept going down, 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 down until it hit 0 and it couldn't go any more down, all right? So that is something that you guys need to look at when you're looking at a chart or a line graph. You're looking at what is happening over a period of time. This could be minutes, this could be hours, this could be days, this could be weeks, this could be months, or this could be years. It could be decades. It could be not centuries, but you get my drift. So let's go ahead and move over to the next part. What I would suggest if as a class, you can go ahead and use some of this information and create a graph. That could be a project that you can do. So let's go ahead and look at this website that I have here. And this is talking about decreasing water levels. Let's go ahead and watch this video.
So what's the story, Sheriff?
You can see for yourself, kids. Reservoir's plumb out of water. Nothing to send down to the town. Right, Trudy? Right, Judy. No water in the reservoir, no water in Sensible Flats. Folks are leaving in droves, and hackers buying up all the land cheap. If we don't find out what happened to the water soon, we'll be a ghost town. Right, Rudy?
Right you are, cuz. We're as dry as a bone. Most often the water level's off right about here, at the 18-meter mark.
Maybe there's a leak.
Nope, no leak. That's the first thing I checked when I saw the water level starting to drop.
When did the water start dropping?
Well, it's hard to say exactly. One day I realized it was lower than ever before, and it just kept dropping until it got to where you see it today.
Do you have any records, Rudy? If you kept track of the water level, it might tell us a story about what happened.
You want records? I'll show you records. Last 25 days worth. See here, all specified and ratified. The day of Betty Lou's wedding, the water level was 17 meters.
And on Milk a Cow Win a Chicken Day, the level was 16. It was 13 the day Bubba came down with shin splints.
But these measurements don't help unless we know the date each measurement was taken.
Dates? Why didn't you say so? Got them all right here, day 1 through 25.
There's got to be a way to organize this stuff.
How can we use the dates to tell us the story?
Well, we could make a graph to show how the water level changes day by day.
And we can use the side of the tank to mark it. Okay, Rudy, let's see what the story is. What was the water level on the first day of the month?
Let's see, day 1, 18 meters. Same day the chicken house caught fire. Never forget that day.
Day 1, 18 meters.
18 meters, mark!
Day 2, 17 meters.
17 meters, Didge!
17 meters, mark! Hate to interrupt a good story, but what do all those crisscrossy lines mean?
These numbers we wrote down here are the days of the month, and those numbers tell us the water levels in meters.
I know that. I painted those numbers myself.
And the lines that crisscross each other make a grid. They show information in a way that you can understand it.
What was the water level on day 3, Rudy?
Lost my harmonica that day. Never did find it.
18 meters, Didge!
18 meters, mark!
So what's the story? All I see is a bunch of dots.
Rudy's right, buckos. That there graph of yours doesn't tell us a thing.
That's because we're not finished.
To see the big picture, we need to connect the dots. Go for it, Didge!
Yeah, that's all, folks.
There you are, folks. Our graph.
But not just any old graph. You're looking at a line graph. It gives a picture of how the water level changes over time.
Well, I'll be. There's a story there after all.
Sure enough, first 6 days of the month, everything was hunky-dory. Water level stayed pretty much the same. But looky what happened sometime around the 7th day. The line starts dropping. Water took a nosedive.
So there's the story. Something majorly changed around the 7th. But what?
Maybe somebody started using a lot more water than usual.
Can't be. Everyone in Sensible Flats gets the same amount of water as everyone else.
Which is a big fat 0 right now.
Anything else happen around the 7th?
Come to think of it, something did happen. That land-napping scoundrel Hacker showed his pointy chin around here again.
So as you see on this video that we just watched, it graphed the information that we had. So go ahead and if you had created a graph with in your notebook, you can talk about why how does your graph compare to the one that they made on the dam, and then answer this question in your class: how does the graph that the Cyber Squad made tell a story? So obviously in the video, you notice that the water was at a normal level, right, at the 18, 17 mark, and then at a certain time, it just dipped down really quick. So in your class, you may discuss, what do you think happened? You know, what could be some factors that made that happen? So you can talk about how that graph made a story, and you can also inference about what might have been the thing that happened. All right, so after you're done with discussing with your class, I'm gonna let you guys pause now. After you're done discussing, we're gonna move on to the next part, and we're going to be looking at this graph right here. Let me go ahead and present so that I have a big screen. So I see a graph right here, and it's telling me that the height of water in meters and the number of days, right? And the graph starts with day one, it has 25 meters, and um, day two has around 17 meters. Day three, you see about 10 meters of water. Day four, you got 10, 5, you have 10. Day 6, you have 10 again, and then day 7, 15, and then day 8, you have 20 meters. So how many days are recorded on this graph? Well, if you're looking at the graph, the way I'm looking at it, you can look at the bottom and it tells me that the number of days, right, is 8. So it has 8 recorded days, okay? What was the highest or lowest water level? So I could see if I look at the highest, well, I'm obviously going to be looking at the meters. So the meters, the highest that I can see here is 25. I don't see any other dot that goes past 25. So my highest water level was 25 meters. The lowest level, I have multiple days with the lowest level. I have day 3, day 4, day 5, and day 6, and they all had around 10 meters. Well, they didn't have around, they had 10 meters. I'm sorry about that. They had 10 meters of water. What happened from day 3 to day 6? So when I'm looking at day 3 and day 6, I'm looking that the line went flat. So what happens during those 3 days is, or 4 days, I'm sorry, is that the water level just didn't change. What could have happened? Well, maybe it just didn't rain, right? Maybe they didn't use any water during those 3 days and the water level just stayed the same, right? So the water level just didn't change. It just stayed at 10 meters. So when somebody asks you what happened during those 3 days, you say, the water never changed. I'm sorry, I went back. So what happened from day 3 to day 6? There you go. So the water just didn't change, okay? So it just stayed the same over time. All right, now that we're done with this, in your classrooms with your teacher, you are going to collaborate and you are going to do the we do section of our lesson, and I'm going to read out loud. Jerry recorded the temperature in his room in degrees Fahrenheit every 2 hours over a 12-hour period from noon to midnight. The results are shown in the line graph. So this is the information that Jerry collected. In your class, you're going to answer the following questions. What was the approximate temperature in Jerry's room at 9 p.m.? Pause the video and discuss with your class. What was the highest temperature Jerry measured? What is the lowest temperature? What is the difference between the highest and the lowest temperature? Go ahead and pause the video and discuss these questions with your class, please. Finally, in your class, you will do the exit ticket. How many push-ups did Chris do last week? For this right here, you might have to probably have a discussion with your class at the end of class. For all the students, thank you so much for listening to my class today. I will see you guys around. Peace out, guys.